Hello everyone. How are you? I hope you're all doing well. Today we are going to learn about the overview of the Rust programming language. It is important for you if you want to create code for your application. Let's get started. Here interface for you if you want to visit the website of Rust. You can visit into www.ras-lang.org. You can see the interface, the blog or the website of RAS like this. You can see install, learn, tools, governance, community, and blog. Why do you choose the RAS for your language programming? Because the performance, reliability, and productivity is very good for you. For example, for performance, Rust is blazingly fast and memory efficient. With no runtime or garbage collector, it can power performance critical services run on embedded devices and easily integrated with other languages. Reliability, rich type system and ownership model guarantee memory safety and thread safety and enable you to eliminate many classes of bugs at compile time. Productivity. Rust has great documentation, a friendly compiler with useful error messages, and top-notch tooling, an integrated package manager, and build tool. Smart multi-editor support with auto-completion and type inspection, an auto-formatter, and more. I have some references for you if you want to learn Rust deeper. You can see on this board many references for you if you want to learn this more. For example, the Rust programming language by Els Klepnik and Nicholas 2018, Rust and Matsakis, and so on. You can see on this board if you want to learn Rust programming language deeper. A recursive version of factorial. You can see on this board in the left side the code of Rust. F and fact underscore recursive and colon U64 become U64 and like this. F and main for E in print learn if you want to display your result using print learn. U64 is the type of unsigned 64-bit integer, and colon U64 is equal and is of type U64. The for U64 is equal, the fn returns a U64 value and extra. For iterative version of factorial, you can see on this board the code like this: f and fact underscore iterative, and you can see let mode I equal let mode result equal, and don't forget to give semicolon in the end of your statement. While e less than equal and curly bracket result asterisk equal I semicolon and I plus equal 1 semicolon, and for your result you can write return results fn main parenthesis curly bracket for e in 1 up to 10, and then you can see your result with print learn parenthesis, and you write your double quotes curly bracket backslash t curly bracket, and you close with quotes. Okay, I will explain you about the variable. For example, let mod I is equal declares a mutable variable I. Let G is declares a immutable variable I. 1U64 is equal, it means U64 version of 1. The compiler figures out the type of I and results. A iterator version of factorial fn fact underscore iterator and equal U64 fn main parentheses for I in 1 up to 10 print learn like this I fact underscore iterator I p m or p asterisk m, it means lambda p m dot p asterisk m. Back to break list from website RAS, zero cost abstraction, efficient, C bindings, minimal runtime. These are performance goals brought from C++. Strobe on C++. C++ implementation obeying the zero overhead principle. What you don't use, you don't pay for, and further, what you do see, you couldn't hand code any better. The prices Strobe is worried about paying are the time and space used by running program. The time and effort binding wounds from repeated shooting yourself in the foot. That is not Strobe concern, but Russ want to avoid both sorts of prices. You can see on this board that the Russ has been better for your safety, guaranteed memory safety, thread without data resist. These are safety guarantees. Why is this a big deal? You can see in here more safety, more control. And for us has been more safety and more control. C++. What is control? You can see in here stack and inline layout, factor, string, factor, semicolon, interior references, auto, and elem equal factor 0 semicolon, and for deterministic destruction. You can see on this stack and heap factor there is elem, capacity, length, data, and string starting from 0 until n in position in the heap, and stack there is data, length, capacity, elem, and extra, and the result you can see in the right side HE. Rust, the feature is abstraction and optimize away to nothing. Ability to define abstraction that optimize away to nothing. You can see on this factor, data length, cap, array 0 until array and data, and cap HE extra, not just memory layout, static dispatch, template expansion. C++, what is safety? Mutating the factor, freed old content. Factor.push underscore back some string. Cout double less than elem semicolon. Factor there is data length capacity elem, and you can see in the array each of these variable data length capacity for data, for example array 0, array 1, and for elem, for example array 0. What about using a GC like Haskell, Java, and Go? Garbage collection. The programmer allocates factors, string extra. The runtime system periodically sweeps through memory, looks for unreferenced data, and delocates it. And we don't have loss of control, we don't have runtime overhead, we doesn't have with other safety issue, iterator invalidation, data races, and extra. So what is Rust solution? The answer is ownership. I think enough for explanation of this matter about Rust programming language. I still have many slides like this, but I will explain you in the next time. Thank you so much for watching this video. Don't forget to subscribe, like, share this video into your friends. See you next time and goodbye.